Hello, my name is Lance Harmon, and this is my AR Sandbox. So, an AR Sandbox is a sandbox with sand in it, and above it, it has mounted a projector and a Kinect. A Kinect is a Xbox 360 3D sensor. It was originally used for video games, and now is mostly used for research and projects like this. It's unfortunately been discontinued as well. But essentially, the Kinect has a depth sensor, so it will sense the depth of an array of points on the sandbox. And then the computer will process that data into a depth map, and then the projector will project topographic lines and shaded in colors that reflect that, which results in a very cool augmented reality sandbox where you can shape things and then watch it reshade to represent the new topography that you've created. This software, which was developed by a professor at UC Davis, has additional functionality that's very cool, which is you can hold your hand above it like this and simulate creating water flow. And that can be used for a lot of different educational things. It can be used for teaching like watersheds, development of different lakes, all sorts of very cool stuff in education. So moving on, this was built with a couple of key design constraints to make it accessible for an educator to use by themselves in a classroom, and maybe moving from classroom location to location. One of the design constraints was the width of the device, being able to be rolled through a standard 34-inch door, which I measured doors at the facilities. I believe that's pretty standard though. The sandbox has to be 30 inches across, which is why there's very little extra past the 30 inches here. This can fit very easily through doors. And the main functionality of that is that it can come apart into many different pieces. So this entire sandbox, I'm not going to do it right now all the way, but it lifts up. And so this entire sandbox can come off, as well as these legs down below. Right here, there's legs on the front, and then on the back there's wheels, which means that you can easily lift this up and move it just like you would a wheelbarrow, to move it from place to place, even though it does have, right now it has 100 pounds of sand, but once I wash and bake another 100 pounds, it will have 200 pounds of sand, which is a lot to carry. Additionally, this back, I call it the stinger, this entire assembly, because it kind of looks like a scorpion stinger. This back vertical support comes off as well. And then this stinger, I'll attempt to show you here, slides up. And I've 3D printed a device that has a number of bearings that act as wheels that roll on the inside of these vertical wooden pieces. And they allow that to slide up very, very consistently and stably and safely. Additionally, so essentially the goal was, my car is not super big. This wasn't designed to fit my car, but I made it so that the feet can come off. The feet and the wheels can come off completely, which does let it fit in my Kia Spectra, which is a pretty small car. This entire thing can be disassembled into like 5 different main components, which makes it very easy to transport. Additionally, there are these fold-out steps that are for children or anyone servicing the top to use to stand on stably. And they also serve to make it impossible for someone to stand on the edge to apply any sort of tilting force, which makes it a lot more stable. Whereas, if an educator had their class of students over there, maybe small children with the step out or not, either way, they could choose to have this out and stand on it if they needed to to like mess with the projector or the Kinect, or they could have it not and just stand and have it at a very comfortable height. It's just a piece of wood. So another very important design constraint for mobility that took a while to figure out is the sand. I have a DeWalt vacuum, and this is not the cord that came with it. I'm going to try and show you, but I have wound, I don't know if it's really visible, in between each of those strands is a copper wire that I've wound around the entirety of this vacuum. And additionally, I have made, oh, 1 second. Let me grab it. I have made a custom bucket lid that's designed to be used to vacuum up the sand while filtering out the small bits. So essentially, one of the major health risks associated with this is using sand. As it gets messed with, it grinds itself into fine particles, and ground silica can cause health concerns. Is fine particles. Any fine particles are just generally not good to breathe. And as it dries out, it can very much get airborne. You would not believe the amount of fine dust when I was washing the sand, which is the purpose of that was removed. But the vacuum attachment allows you to both simultaneously move the sand very conveniently by just vacuuming it up rather than scooping it and dealing with a bunch of small, well, millions of small sand particles. And it puts it conveniently in buckets while filtering out the potentially dangerous health hazard. Oh, and the copper wire that I mentioned on my vacuum helps with a very annoying problem, which is when you're vacuuming a huge amount of sand, or not huge, large amounts of sand through a plastic tube, it generates a tremendous amount of static electricity, which hurts. It hurts a lot. When I first started using that filter, it was quite painful because it would shock me just absolutely constantly. I mean, it's like rubbing a balloon against your head, except the balloon is like thousands of little particles, rubbing off all their electrons, or however that works. So I believe that's it for now. Let me start this, which is my phone. It's just clamped on there. That's what that is. That has a better view of the display. And I will turn off the lights for demonstration. So, I've always started with some water in there. Probably happened when I was holding my hand above it. So this is the AR sandbox. Right here I have made a sort of mountain with a crater in the center, which is what's being reflected here. The lowest topography is shown as blue. You can imagine that as like seawater or just low-lying plains, I guess. I feel like it's kind of intended to be seawater because it's blue. And you can notice some speckles here that are simulated water. So there's a couple things we can do. One is, as we change anything, the sand, there's only half of the sand is in here. You can see it will update, like rescan and update the topography as soon as you're done messing with it, which is very fun to mess with. But as well, you can see this darker thing right there. That is actually simulated liquid. So we can hold our hand above it, and just like that, see, we are creating more water inside of there. And this water, its path that it would naturally run and where it would accumulate is then simulated. So for instance, if we want to create a river, we can very easily have it run out of the crater and down into the ocean, or whatever this is on our island. I guess that this is an island and it's the ocean. Yeah, and there's a lot of settings for the water. You can change like how fast it flows, obviously. you know, the entire lake draining in some sort of cataclysmic event isn't probably something that teachers would be teaching. You know, maybe it is. I don't know. But you could make it flow slower. You can add more water. Like if you want to show a watershed, you can. It's difficult to get it to work sometimes. There we go. See, you can see the water flowing down into the ocean. So yeah, there's a lot of very cool potential for teachers to use this alongside other resources for education. If we want to remake our crater, just easily fill it back up with water. Smell it a lot. Let's add some more. So, oh, you know what? Here. I feel like this is more. We'll make a nice, pretty snow-topped mountain. There we go. So now, I'm actually going to immediately destroy that to show something else, which I'm hoping that the projector will be able to show my screen well enough for me to be able to share projected onto this without me having to switch another camera angle. So this is the terminal. What we can do is this is a screenshot that I've taken of the entire AR sandbox. That's not the active sandbox right now. That is in a screenshot. So by changing the height map, which is the height color map, it's the colors that it shows at different heights. I was able to, with some programming, get this, which is a grayscale version, and then run that through this, which is it's difficult to see. That's a rotating 3D STL file of the topography. Here, maybe that's a little more visible. So then this STL that is now being displayed is representative of that topography, and that could then be exported to a 3D printer and printed on the spot. And the goal is to get a 3D printer that can accommodate multiple filament colors at once, where the different filament layers, it would have like say 4 different layers, and each layer would be a different color. For instance, the first layer could be light blue, the second layer could be green, and then like orange and then red, so that it would mirror the same thing that students had created. So students would be able to, you know, take home a little model, like a small, you know, token of the thing that the class had created, regardless of what it was. Like you could make any shape and then have it be easily exported to a 3D model through that functionality. And I have a spare 3D printer that I hope to incorporate for that. Although it wouldn't be mounted on the device, because the device is quite full. So it doesn't really have a whole lot of space. Also, sand and 3D printer, not a great mix. But yeah, that's my sandbox. It still needs a little. I'm gonna put like a grill or something there. But otherwise, and you know, these cords would of course be running through the stinger and down into the base. The computer would be mounted again underneath here, which is totally accessible if you were to remove the sand and lift off this lid, which is quite easy without hundreds of pounds of sand on it. Yeah, that's all. Oh, actually one more thing. Also, I made a couple tools. This is a calibration tool. It's just I just took some more of the copper wire that I used for the vacuum, made a little handle. So this would allow an educator to very easily follow a calibration procedure where you would just hold this in a certain spot and then press a button and then move it to a different spot, press a button, and it takes about 5 minutes. And it would fix any misalignment that naturally occurs between the sensor and the projector. And also, this is a piece of video game architecture, but 3D printing and this, I think, are a fabulous mixture. This, if I, well, this dam is fully recognizable by the Kinect. Like it is able to sense if you put this in topography, and it does a really good job of actually functioning as a dam, where like if you generate water, the water will flow and collect on it, and then if you were to remove it, it would, you know, it would then flow onwards. So I think there's a lot of potential for like students designing things that are, and 3D printing them and putting them in here to test, you know, whatever functionality, or just, you know, make a dam and see it in use. I think that is a very cool opportunity. And I have done a tremendous amount of 3D printing. Almost many of the parts of this, especially the ones things that are inside and not visible, are 3D printed. The main piece being the mount for the projector and Kinect, because it takes a lot of calibration. So yeah, that's my project. I'm sure proud of it. That's all. Thank you.